So above the gamma is given to you as 16 kilometer per meter cube, and then gamma is given to you as 20 kilometer per meter cube. So in this case, if I'll just check, if I'll draw the stress diagram, so from here to here, your effective stress will vary like this, right? So the magnitude of this length
32.
will be 16 into 2, 32 kPa. And then
4
from
meter.
here to here, you are having 4 meter, right? Why
Yes.
4 meter?
Sir, 20 into diameter, so
Yeah.
it's getting
So your critical depth
6.
is 20 into 0.3 equals to 6 meter.
It's getting 6 meter
So that means you
total
need to
depth.
consider the increment in the effective stress only up to the 6 meter. After that, your effective stress you won't take into the account into increment. So
It
we'll
will
take up to
be
here. So from here to here, it's your 32, and then from 4 into your this part, since from here the water table is getting started, and here is your 32, and this is your basically 20
40.
minus 10 because this is submerged, and this is your 4. So overall this will be 72, right?
7. Yes, sir.
And again up to here, since your effective stress will remain constant, so up to here again you will be having 72 kPa, right?
Yes.
So now let's solve this. So first we'll calculate the skin friction from 0 to 2 meter.
So it's 1 half into 32
So
into
that will
2.
be sigma dash b
Sir,
k tan delta, right? So sigma
yeah.
dash b is
Sir,
so
I take overall directly, like 1 half into 32 into 2 plus 1 half into 32 plus 40 into 4
okay,
plus 72 into 8.
okay, then
And
let's do
afterwards,
this.
I have
So fs you are having uh, half sigma dash
into
b, right?
32.
So sigma dash is half into 32, k is 2,
Into,
and then you'll be having tan delta, right?
yeah, but sir, I calculate directly, like for all,
No,
not
but
a
for
particular
all,
one.
have you also
That
taken the surface area into account?
uh, afterwards, sir, like commonly multiply that.
No, but
Like I take
for
a
this, the
triangle.
surface for this the surface area will get vary, right? For this also it will vary. This will also it will vary because pi d l. So in every case your l is getting changed. So have you taken that thing into account?
No, sir.
So that's what. So we'll calculate separately. That will be easy. So
Okay.
fs equals to 0 to 2 half uh, into 32. So sigma dash v k tan delta, and k is your 2 tan delta. Tan delta is how much? 0.755 dash. 5 dash is your 40. So this will be tan 30. And this is your sigma dash v. And then we'll multiply basically with the area. So that we'll do afterwards. So first you can calculate this. Then fs skin friction stress, which is up to 2 to 4, will be half into 32 plus 32 plus 72.
No, sir. 32 plus 40. Uh, Only
32 plus
we have to
72,
take
right? We
trapezoidal area.
need to take this and this. K 10 30, and then Fs is equals to 4 to, sorry, this is 2 to 6, this is 6 to 14, half into 72. So we don't need to take half because it's simple.
Sir,
72
72 into 8.
10 2 into 10 30, right?
Sir, we have to multiply by 8. 8 no? It's rectangle. Total lateral pressure area we have to consider.
No, we are just calculating the friction right now. So first we'll calculate that, and then we'll multiply with the area to get the pressure force. So let's do this. So this is the FS1, FS2, FS3. So now to get the total friction force which you are getting, so this will be Fs1 into pi into d 0.3 into your this thing 2 meter L. Then this is your Fs2, this will be again into pi into 0.3 into your 2264 meter, and Fs3 into pi into
0.3 into
8. Okay, so now just substitute this. Sorry. So we'll calculate this. So the PU is none other than pi into d into, first you need to calculate the Fs1. So how much is this value?
1 minute. 0.5 into 32 into 2 into 10 30. 18.47.
18.475, right? This will be your kp, and this is your half into 32 into k sigma dash v. So this will be kp. Okay, so this will be your 18.475 kp, and let's move to the Fs2. So how much is this value? So 32 plus 72 into 10 30 equals to,
It's 1 minute. Sir. 60.04.
60.04 kp. Okay.
Yes.
And what about this? 72 into 10 into 10 30.
72 into 2. 83.13.
Okay. So this will be your 83.13 kp. So now solve this. So this will be your pi d. So first pi d is your 0.3, right? And then fs1. So 18.475. L1. L1 is your 2 meters.
60.04.
Then fs2. 60.04 into 4. 83.13. 83.13 into 8, right? So just
Yes, sir.
calculate this.
Into 73 point.
At the same time, we'll calculate how much is the base resistance which is available. So which is
Sir, it's 887.87.
887.87
87.
kilonewton, right?
Yes, sir.
Now moving to the base resistance which we need to calculate. So pi by
0.
4 t square 0.784
It's
into
0.07.
area 0.3 square. Okay. And then we need to multiply it with the C and Q and Q. So the stress which is available at the base is 72, and then we need to multiply it with the NQ. NQ is 137. Did you get this? How we did this?
No, sir. Can you please repeat
See,
it?
this is basically this expression. So this is your pi by 4 d square Q and Q. So your basically the overburden which is available at the base is 72 kPa, which you can see from here,
Yeah.
right? Which is
Okay.
72 kPa. And your bearing capacity factor is 137, right? So that's why your
Okay.
pressure at the base, if you will calculate this, how much value it is?
0.74 into 3 square into 72 into 137. So 696.00. 3.
696.00 kilonewton, right? So this was your shaft friction and this is your base resistance. So if you calculate the total load at the bottom, so it will be your PUS plus PUV, so which is your 887.87 plus 696.00. So if you sum this up,
1583. 1583. 83.
1583.87,
3.87.
right?
0.87.
Kilonewton. So yeah, I think option B is closer. So let's assume it's near to 185 kilonewton. So this is the answer which you're getting. So correct answer is option B. Yeah. So correct answer is option B, 185.585 kilonewton. So are you clear with this?
Yes, sir.
Okay then. Let's move to question number next question. Okay, it's marked already. Oh, mark this. Okay, no worries. So basically, we go for the pile foundation when the loads are heavy and we need to transfer the load. The soil stratum at the bottom is weak. So that's where we basically use the pile foundation. Okay, I think I shared the wrong slide. Okay, this was already there. Yeah, so this is the part. So where do we generally use the pile load test?
Sir, both A and B.
Yeah, let me check. So yes, we basically go for the pile load test is generally useful to determine the ultimate bearing capacity, yes, and evaluating the settlement of the pile. Yeah, so both option A and B are correct. So we can use for the pile load test for both the cases to determine the ultimate load bearing capacity and as well as this thing. Yeah. Then let's move to question number two. So the efficiency of pile group depends on which parameter?
Sir, all of above.
Yeah. So basically the efficiency of the pile group depends on like how much the group is able to transfer the load as compared to when the each pile individually is taken and the superimpose and their entire capacity is superimposed. So yes, it depends on the spacing of the pile as well as the type of the soil which we are dealing with and also the characteristic of the pile. So option D is correct. Moving to question number third, you are having a 300 diameter pile, um, which is 10 meter of length and are used as a foundation for a column in a uniform deposit of clay, which is Cu is equals to 50 kPa. The spacing between the piles is 750 and there are 9 piles in the ground arranged in the square pattern. Efficiency of the group as per the converse Laber formula is.
Sir, it's 0.67.
Yeah. So the correct answer is 0.67. Let's check. So what is the formula to calculate the efficiency as per the converse Labaire formula?
Sir, 1 minus tan,
Minus
inverse tan,
tan inverse.
tan inverse, d by s for theta.
Yes. Yeah.
In and sir, it's n minus 1 into m plus n minus 1 into n upon 90 into mn.
Right. So basically, where your m
is 3 and n is
yeah. So this is your m and this is your n. So m is basically the number of rows and n is equals to number of columns. Right. So your m is 3, your n is 3. So if I calculate the efficiency, so it 1 minus tan inverse d by s. So d is how much? 0.3. And
divided by
spacing is 0.75.
It's
So
sir, the in degrees is 21.48 theta.
So how much is this value? 0.67, right? This whole value.
No, sir. It's closer to that 0.681. So I take 0.67.
So assume this as 0.67. So the correct answer is option B. Let's go with that. Let's move to question number 4. So you are having a group of 9 piles, 10 meter long and 300 mm in diameter. It is arranged in a square pattern in a clay soil with an average unconfined compressive strength of 60 kPa. What is the ultimate load capacity of the group piles on the basis of the individual action and without considering the efficiency factor? Assume adhesion factor is 0.9.
Sir, B option 2290.
290, right? So let's check. So in the question, it has been asked like you need to evaluate the ultimate load capacity of the piles on the basis of the individual action. So let's say this is your pile which has been arranged in the group action, and this is a top view. So it's basically the 9 piles and the total length is 10 meter. D is 0.3 meter. It's arranged to be in a square meter. So the unconfined compressive strength is going to use, so you can calculate the
60 divided by 2.
cohesion, which is Ku by 2, which is 60 by 2. This is none other than your 30 kPa. Now it has been asked like you need to calculate the ultimate capacity of the group pile. So P of group. Now they are asking you don't need to consider the uh, efficiency factor, and also you don't need to take into account the bearing capacity. So we can directly calculate the shaft friction capacity for each pile, and then we can multiply it with the total number of piles. So total number of piles is 9, and capacity of each pile, since it's a cohesive soil, so addition time, your Cu, and then your shaft friction area. So 9 into alpha is how much? 0.9. Cu is 30. A is again your pi into 0.3 into 10. So how much you're getting this?
Sir, I getting is 2290.22.
Okay, so you get 2290.22 kilonewton. So which is closer to 2290 kilonewton. Okay. So it was straightforward. You don't need to consider the group action. You just need to consider the individual action, and then you can multiply it with the total number of piles. Moving to question number 5. In the question number 4, what is the center to center spacing of the piles if the group efficiency factor is 0.7?
D answer.
What are you getting? Answer D.
Yes, sir.
It's been given to you. It's D. So how did you solve this?
Sir, number of files into a single file, like we did in last question. So efficiency factor 0.7 is equal to QU upon number of files into uh, what, yeah, 254, like a single file capacity. So by that I calculate.
Okay. I'm not sure. Maybe it can give answer, but the correct approach is to again go with that formula where we have used this particular the converse Labre formula, right? So you can again utilize this since you already know the efficiency, right? So it's your 0.7. So neta is your 1 minus tan inverse D by S into M. What was the formula? It's M minus 1 into N plus N minus 1 into M into 90 into Mn, right? So we know your neta is 0.7. This is your 1 minus tan inverse. D is your 0.3. Spacing you need to evaluate. Then this again 3 into 2 plus 2 into 3, 90 into 2, 90 into 3 into 3. So that's also you can calculate. So let's see how does it work. So it's 0.3 tan inverse 0.3 by S. How much is this? 3 into 6, 6 plus 6, 12, 90 into 3, 990, 810. So tan inverse 0.3 by S is your 810 into 0.3 divided by 12. So that will basically give you how much? 810 into 0.3 divided by 12. Tan
20.25.
0.36 and 0.37. So that will be 0.3 by S. Point 0.37. So how much you're getting? Tan of 20.25. Have I made a mistake anywhere? Okay, we will get the spacing in meter. This is your 0.36. So 0.3 by S is equals to 0.37.
is equal to minus 10 numbers.
So your S is none other than 0.3 divided by 0.37, which is your 81. Okay. So answer I'm getting is 0.8108. Okay, it's in meter. In the question it has been asked in the mm. So 81810 mm I'm getting. So which is closer to option D. Yeah, 813 mm. Okay. So did you
Sir,
get this?
on calculator, I directly get 813. But sir, can you please repeat? Tell me the 810
Yeah.
into point 3 upon.
Do you want me to tell the procedure? Is it?
Yes, sir. 10.3 upon S is equal to that procedure.
Yeah. So this 0.3 upon. So first we have taken this converse Labre formula to evaluate the efficiency. So efficiency is given to us 0.7, right? So now efficiency is given by 1 minus tan inverse d by s into m minus 1 into n plus n minus 1 into m upon 90 into mn, right? So in the similar fashion, you have been given, if you solve this, so every value is given to you, neta is given to you, d is given to you, 3, m is given to you, n is given to you. So the only task for you is to evaluate how much is the s, right? So for the calculation of the s, what you guys need to do, so you need to swap the things here and there. So first I'll have multiplied
Okay.
810 into 0.3 divided by 12. So you'll be remaining on the left hand side tan inverse 0.3 by s, and this is 810 into 0.3 by 12. So
Okay.
I
Okay.
got the value 20.25. I took the tan of 20.25 and I got this 0.37. So I skipped one. So I have solved this. I have taken the tan of this, and this is giving something equivalent to 0.37. And then you need to calculate the s. So you just need to divide zero point 0.3 by 0.37, and then you will get the s.
Understand, sir.
Got it?
Yes, sir.
Okay. Then let's move to question number sixth. So, which of the following formula can be used for determining the efficiency of the pile group? So, please. Okay, we have already solved this, I guess.
Converse Laplace formula.
Yeah, it's option C. Let's move to question number 7. So you are having a pile group which consists of the 9 piles. It's arranged in a square pattern in clay soil, and confined compressive strength of the clay is 100 kPa, gamma is 18 kilonewton per meter cube. The diameter of each pile is 0.5 meter and the embedded length is 10 meter. Center to center pile spacing is 1 meter. Then you need to determine the allowable block capacity of the pile group using a factor of safety of 3, and the adhesion factor is 0.9. Shall we see this?
1 minute, sir. 1 minute. 11756 0.86 divided by 3 2385. Sir, I am getting 2385.62. Answer.
The block capacity.
Block capacity, sir, I getting is 7812.5 divided by 3. It's 7812.5 divided
A
by
little variation in answer. Let's just check.
2604.
So it has been given. Let's say you are having a pile group which are consist of 9 piles: 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is your top view, and if you, let's see, you are having this thing. So this is your another view. Okay. So this is the part which you are getting. You are having. So there are basically 9 piles. In the front we will see the 3 piles. So from center to center, if you just check, the total spacing is 2 meter, because between each pile it's 1 meter, and the diameter of the each pile is 0.5 meters. So this is the radius of each one is basically 0.25, and it's 0.25. Again, this is your 2 meter, and this is your 0.25, and this is your 0.25, right? So the total dimension which you're getting for your block is your none other than it's 2.5 into 2.5. Okay.
6.25 EG.
2.5, right?
Yes, sir. AG, I am saying AG is
Okay,
6.
okay, okay, okay. So let's see the capacity. So first will be your frictional capacity. So that will be your Fs into As, and then you'll be having the tip bearing capacity, which is your Fb into base area. So your Fs is none other than alpha into Cu
C.
into
Uh,
As, right?
pi, pi into D into
And this will be your Q and Q.
CU into
Okay, C and C. So
NC into CNC, sorry.
Cu into and C into your base area, right?
Basically.
So alpha is 0.9, Cu again
50.
unconfined. Okay, so your Cu is Qu by
100 of
2,
F100.
100 by 2, so that will be your 50 kPa. So its Cu is 50. Ace is
Into
basically your 4
pi
into 2.5 into L 10. Did you get this? So
yes, sir.
4 into 2.5 is basically your parameter, and when you multiply it with the length, so that will be the your longitudinal surface area. And then Cu again is 50. How much is NC?
9.
Strength. Okay, it's 9, right? Yeah. and base area is your 2.5 into 2.5. How much you're getting this?
Uh, 1312.5.
1312.
Sorry, 73112.5.
Okay. Okay, even I've made a mistake here. So since this is not your strip footing, this is your basically the square foundation. So instead of multiplying with 1, there's another factor which will come will be 1.3 times CNC. So
Sir, I think I am also make one mistake in calculation. I take one pile only. I am gonna take
okay, that's
total
fine.
pile, and afterwards I multiply with 9. So I think that's it.
And
I
also
get
n
wrong.
value is also we have taken wrong. So CU it's 50 and ANSI value is basically 5.14. So whenever you are having pi as 0, so then your ANSI value will come out will be 5.14.
5.17.
Okay. So now let's see this. So I'm getting it at 6588.125. So now the PU save which will be allowable will be your PU by 3. So which is 6588.125 by 3.
Sir, it's 2196.041.
2196.041. Okay, so this is your capacity. So the correct answer is option A, 2196 kilometer. So are you clear with this?
Yes, sir.
Okay, then let's move to question number 8. So for four freestanding pile group having an arc 10 value of d by s 18.5 in degrees. Uh, okay, again you need to calculate the efficiency as per the Converse-Lebesgue formula for four freestanding pile group. So did you get this? What is four freestanding pile group? So
Yes, sir.
this is this.
N is 2 and M is 2.
Yeah.
N is 2
So
and
it's
M is
easy. Just put the value and get the answer.
2. Yes, sir. One is 10 is S d by S is 10.5. 1 into 2 plus 2 into 1 upon 90 into 2 into 2. So 1 minus 10 inverse 13.5. Yeah. This is 3 minus Sir, I don't getting the answer. I think it's showing me 1.
So the formula is this, right? Neta 1 minus tan inverse P by S plus n minus 1. Basically 90 divided 1. So neta 1 minus tan inverse D by S is basically your 18.5. So arctan value of D by S is 18.5. 18.5 degrees. I think in radian that would be 18.5 into 3.14 divided by 180. So how much is this?
0.32.
0.32, right?
0.32.
So this is 0.32. M is basically your 2, N is your 2, so 1 plus 1 into 2, 90 into 1 into 2. So neta is equals to 1 minus 0.32 into 2
Sorry,
plus.
it's 2 into 2, bro. M into N. So 2 into 2.
Oh, sorry, it's 2. Yeah. So it's basically 90 into 4, which is your 360, right? So 1 minus 0.32 into 4 by by 360, which is 1 by 90. So 1 minus 0.32 by 90.
0.99. Okay.
So how much is this? It's very large, right? Have we done any mistake anywhere? 10 versus S.
0.99, sir, I am getting also.
18.5.
Sir, same answer I am getting. 1.
Yeah, but I guess here this tan inverse value we need to put it in the degrees only. So
Sir, but also I get same answer.
then also you're getting same answer, is it?
Once again I recalculate it, but still I get same answer.
Minus 18.5.
Divided by 19 to 22. Yes. No, 0.79.
How much it is?
0.79.
0.79. Yeah, the answer is this. So your neta value is basically 79.4 percentage. Yes. So the correct answer is option C. Shall we move to next question?
Yes, sir.
Yeah, let's move to question number 9. So the load carrying capacity of an individual friction pile which is given to you is 200 kilonewton. What is the total load carrying capacity of group of 9 piles with group efficiency of factor of 0.8?
Okay. N is equal to Q upon N into friction 0.8 is equal to Q upon N is 9 into 200. So 9 into 200 divide. So it will be into 0.8. Sir, 1440 kilonewton.
How much you're getting?
C, 1440.
What will be now is you are basically having the load of individual friction pile. So the load carrying capacity of an individual friction pile is given to you, which is 200 kilonewton. So what is the total load carrying capacity with a group efficiency of 9 pile with? Okay, so neta is your none other than
0.8.
Capacity of group versus n times individual capacity of individual. Right. So neta, if you check, it's given to you as 0.8 capacity of the group.
Not given, sir. It's not given, sir. So
Okay, that
divided
you
by,
need to determine, right? Capacity.
yes, sir. Upon 9 into 200. So it's getting 18. 00 into 0.8, so it's 1440.
0.8 into 9 into 200. So 9 into 2, 18, 18 into 8, 1440 kilometer. Great. So the correct answer is option C, which is your 1440 kilometer, the best. Let's move to question number 10. So you are having a 300 diameter pile, 15 meter long. It is driven in a normally consolidated clay deposit of great depth. For the soil, C equals to 80 kPa, adhesion factor alpha is equals to 0.8, and a factor of safety 2. What is the allowable load carrying capacity of the pipe? So diameter, which is given to you, is 0.3 meter. Length is given to you as 15 meter. C is given to you as 80 kPa. Alpha is given to you as 0.8.
0.8 into
And
80
factor of
into
safety is given to you as 2.
15.
So what is the
So
allowable load carrying capacity of the pile in kilonewton is
0.8 into 80 into 5 into 0.3 into 552. I'm getting answer. 0.38.
but the option is not here.
So like 0.8 into C is cohesion. So
So
alpha into
QU
cohesion.
is okay, it's not about the group pile, it's about the individual pile, right?
Yes, sir.
So
So that
Q is equals to C and C into
sir,
AB, right? And yeah, please tell.
sir, alpha into C cohesion into area. Use that formula
Okay. And have you taken
because
the
in
base capacity also? So C is 80 and C value again, how much you have taken?
9.
And C
Sir,
value is
I don't take C and C plus AB. I have to, I think, take that.
yeah. Then take that into account. And then AB
Five,
is your 0.784
3 square.
into 0.3 square plus alpha is your 0.8. Cu is your 80 and AS is basically your
50.8
pi into D into L. L is your 15. So if I'll evaluate QU,
4.77. So
how much
955
is
divided by
this?
2. 477.83. Sorry, it's 955.66.
955.66 kilonewton. And your QU allowable will be QU by 3, right?
Yes, sir. Sir,
Better.
I think so you don't take.
Yeah, please tell.
No, no, that's uh,
Okay.
2, sir.
So, okay, 2.
QU upon
Factor of safety is 2. Okay. So how much is this value? It's
1, yeah, 477.83.
477.
But
Okay, how much I'm getting? Yeah. So it's closer to 477 kilometer. Yeah, so it was straightforward. Let's move to next question. Okay, I think that time is already over, so we can wind up with this thing today.
Yes, sir. No, sir, I think the time is there.
Do you have any other doubt apart from this?
No, sir. Right. No, sir.
Yeah, so I think we can call it a day. Thank you so much for joining. Those who are watching these videos at a later stage, you can uh, post your query in the comment section of the YouTube video. We'll definitely address your query over there. Thank you so much for joining. We'll see you on next Tuesday.
Thank you, sir.
Thank you, Sudhanshu.